Hello all, today I'm going to discuss about some basic concepts in electrical engineering in this short session. As an electrical engineering student, it is expected that you should have better understanding on these basic concepts. Before the kick start of the session, I would like to introduce myself in a short. I'm Dr. Akbujaman Shah from the University of Manchester. I'm based here at the School of Electrical and Electronic Engineering as a postdoctoral research fellow. I have been doing teaching and research in the field of electrical engineering, principally in the power system dynamics, high voltage DC transmission system, renewable energy application since 2005. So this is all about me in a brief. Okay, these are the specific outcomes of this session. At the end of this session, it is expected that you should be able to define electrical engineering in a better way. You will be able to clearly identify what are the fields in electrical engineering. You will have a better understanding on the basic concept in electrical engineering. Now I'm going to define what is electrical engineering. So electrical engineering is related to the electricity and the various applications of this electricity. Definitely it is a profession which is related to the transmission, measurement, distribution of electrical signal. So in a broader respect, electrical engineering is something which is related to the concept development, design, product generation for electrical and electronic equipment that is needed for our day-to-day life. Now let's have a look what are the fields associated with the electrical engineering. The first one, the most important one, is power system. We can't imagine our life without power system. So the generation, transmission, distribution of the power, their control, storage, maintaining them, all related to the electrical engineering. The second one related to the electrical engineering is the control. This control can be for the industries, this control can be for the ship, for the aircraft. In everywhere there is a control. So designing of this control, advanced control, is associated with the electrical engineering. We all use different devices in our day-to-day life, and most of these devices contain integrated circuit. Some of them also have microprocessor. Designing of this integrated circuit microprocessor for these devices are also related to the electrical engineering. Fourth field of study which is associated with the electrical engineering is telecommunication. We all have mobile phones, conventional phones, smartphones. So voice and data transmission through these phones or devices also needed electrical engineering. The fifth one is the computer. We all have computer at home or we all use computers at office. Design and advancements of this computer system is also related to the electrical engineering. The sixth one is instrumentation. What does instrumentation mean? Instrumentation means is sensor data acquisition. So we have a speedometer in our car. We can have an electric thermometer at our home or office. So designing of this sensor and data acquisition is also associated with the electrical engineering. Now, these are the basic concepts we are going to look at today's session, starting with electricity, then we will move to the charge, definition of current, definition of the voltage, and then we'll end with power and energy. Now let's look at the electricity. What does the electricity means? Because electrical engineering is related to the electricity and their application. So the term electricity is actually related to the charge. It can be static charge or it can be dynamic charge. Dynamic charge means the charge is in motion. So this is the main reason, the charge is the main reason why the electrical current is made. So in a brief, electricity can be defined as a physical phenomenon related to the existence and interaction of electrical charge. Now let's look what does the charge mean. Charge is the fundamental property of the atomic particle or the matter, and this need to be conserved. That means it can't be generated or can't be destroyed. And we know that there are two charges in atomic particle. One is the positive one, another is the negative one. The negative one is known as the electron and the positive one is known as the proton. And the existence and the interaction between this positive and negative charge is the main fundamental reason why the electricity is generated. This charge has a unit, and the unit of this electric charge is coulomb. Charged particle shows some specific characteristic. One of that specific characteristic is force. If two same charges are bringing together, very close together, in this case two electrons, we can see from the slide, then they will show the repelling force. If we bring together one positive and one negative charge, then they will show an attractive force to each other. So this attractive force is the main reason why the atoms are held together. Now I'm going to define what is electric current. So far we have learned about the motion of the charge, specific characteristic of the charge. Now, if the charge is flowing through some conductive material or some ionic solution from one place to another in per unit time, then that is electrical current. It has a unit which is known as amperes, and it's related to the movement of the charge in per unit time. Now I'm going to define what is electrical circuit. Electrical circuit is actually a closed path through which the electrical current or the dynamic charge flows. So if you look at your slide, there is a simple circuit example which has a battery and a resistor. Battery is the representative of the source, resistor is the representative of the load, and they are connected through the conductive material to make a closed path for the current flow. So we have defined the electrical circuit through which the current flows, but there need to be some force that make the current flow, and that force is voltage. It can be defined from the fluid analogy. If we have A and B point, and A point has a higher pressure than the B point, then it is expected that the fluid will flow from high pressure point to low pressure point. So in your slide, we have 2 points, A and B. If A has a higher potential than the B point, then the electrical current will flow from A point to the B point and vice versa. So most of the cases, this voltage can be defined in a different way. If we are doing with the simple circuit, then it can be defined in terms of ground. If we are doing complex circuit like in transmission system, then it can be defined in terms of line-to-line voltage. Now a little bit more about the voltage. Voltage has a unit which is volts, and this volt can be defined in terms of joule per coulomb. That means if you want to move 1 coulomb of charge, and if you need 1 joule of energy to move that charge from one point to another, then that is related to 1 volt. So we have defined so far electricity, the charge movement, and the current and voltage. Now we are going to define what is power. So power is actually the time rate at which the energy is consumed or produced. In another way, this is the product of current and voltage. So it need to be signed properly. That means if it is generated, then power can have a positive sign. If it is consumed, then power can have a negative sign. And the unit of the power is watt. In summary, so far we have discussed what is electrical engineering. Then we have identified the field of electrical engineering, and then we reviewed the basic electrical principle. Next session, we'll do some numerical examples related to the electrical circuit elements. Now, these are the references. If you are interested and want to learn a little bit more about the basic principles of the electrical engineering, then you can follow these 2 books. Thank you for listening. If you have any questions, please feel free to ask.